Welcome back to Wickerson Studios. My name is Michael Wickerson. I'm continuing to process the Machine Learning Chapter 4 section of the Python one-liner book, but of course I'm bringing it into Grasshopper through the Python Remote Node plugin. And I've done very well with these scripts. This will be the 4th out of 10. I'm very excited about this chapter to finish this full script. And you can see here I've brought in sklearn neighbors for this one. And I have it up and running. It's been brought in through the modules and it has a nice output. As long as I import statement this way, I can have it in my Python scripts and I can create my user objects. So we've gone all the way down here and I've started with a very simple script on nearest neighbors. Pulled that pretty much that you've got ages. This one's actually an example of a size. Say there's a square feet of something. This is the price of that. Or say this is just the size of something referenced by whatever unit in numbers, whatever you want. And then this will be the price of it. So if you had a prediction of 82, that would be the price of that. It's estimating about $109. If I go back here and take the edit and pull it back down to something within that framework, 58, it's probably going to get a little closer. Let's see what it says. 58 is, nope, it's still 109 as the predicted number. Is the price going off to that? Let me see if I have this all up and running. I thought that would have been it. Or if I change the prices, there you go. Now I'm starting to have an influence. Maybe I just had to run it. 58 at 1. Yeah, there's an estimate there. So it's saying at 58 square feet, it's going to estimate the price to be 124. That seems about right. So that's a nice predictive model for what you're doing. Very excited about it. Throw in a little analyze here just to make it look pretty. I do like the zebra, and there we go. We've got something nice, and that is not the geometry we're working with, but it's a nice visualization of what's actually happening. So if you're looking for visualization, data visualization, creative data visualization of that, contact me, Michael Wickerson, and we'll see what we can do for you. That one's actually running, so that's fine. I do have a lot of notes that I bring into the node to learn what's happening through the K nearest neighbors algorithm. And then I specifically talk about the details of one code, well, without going too specifically, and then I prepare for the next model, which will be neural networks. I'm very excited to get on to. So what I did was I brought it in again, but I changed it up as an example. And what I chose here, if you consider these bits of data, I don't need to show the, and I'm also not content in my scripts to hard code in an array. What I do is try and make things as parametric as possible, so as few numbers on here as possible. And I think that's why my user objects are interesting, because you can really take them to different geometries and different point sources and point attributes and have a real fun time with it. There's a lot of extra data in here if you're interested. Hopefully I didn't crash out. Good. But basically, let's look at this. If these were the, say, sizes of certain things, and these were the prices of those things, those costs, and you had a sample set of all of these. Now I'm bringing in the predicted numbers as a list. Then I can estimate this list, and of course that's all dependent upon not just that list, how close that comes to the initial list, and then what I end up doing to the steps between the pricing. So I'm going to pull the pricing back down here, edit to a smaller, let's say like $5 in between pay scales. So it's going to drop down this numbers quite a bit here. There they go, down to 28. And then because I'm predicting those numbers and making estimates there, let's see what that does to the final data. Actually gives me some 19s and some 24s. The other thing is you can change your number of K. I've only got 2 here. Let's bring this one back up to 4. I hate to do this. I always like to lock my solver whenever I'm working with machine learning algorithms. Let's see what 3 did. 3 generated 16, 22, and 22. Actually, those numbers are pretty small. What did I do? I think I am going to keep the difference here, editing up high in the prices. We'll put it up to $40. That might be a little outrageous in the numbers of what's coming. We'll see how that changes down here. There we go, up to 400, 200. We have all of those. Just freezing up a little bit. And now I have, nope, still 2 ranges in the numbers playing with the data. I'm going to bring my KNN up a little bit to see how many neighbors I want. And then I might fudge my data at the beginning, but I am estimating around the same point. I think my numbers here might be a little too high. And they're all falling out at the 121 estimation there, the prediction. So it might help to bring this one back down to where it was, say around 7, and see what we have there. And that's just going through a series of 1 to 6 of predictions. No, I'm still left with the same data. Give me a second, I'm going to play around a little bit more with these numbers. What happens if I have the k-value set back to 4? Okay, now I'm getting a couple more. I don't know my outcome, so I'm really playing parametrically with what's going in to these algorithms that are machine learning algorithms, and I actually really enjoy it. This one I don't want to take away from the actual set. Let me see. I'm probably going to crash it out. There we have a whole set here of 1 to 18. 3 here. My data is splitting the data, but not really enough. Crank this one up a little bit. Get the ages ranging a little higher. So we're going to go up to 20 years old. This one's down at 17. This is up to 203. I think that's probably it, is that I have such a high step count on this one for for this one has such a high dollar value step value. So let's just bring that one down again and see how we fudge the numbers up. And what I'm doing is I'm going so far into the data that's driving this, and I'm not dealing, but I want to have it make some interesting geometries and have many sets. So I brought that down a little bit. I've got 16, 33, and 50. So that's driving data in a variety of different ways. Not as many as I would imagine I could do. Maybe just to make this script a little better, I'll just bring it up to 30 max, and I'll bring it down to a very low count, like $2 in between. And because the data is getting closer to one another, it's going to have some different predicted values and allow for some different ones. So you're kind of getting to know how this thing works. There's 3 different values. Again, very small. So that's going to have an effect on the geometry as we plug on through. Let's see if we can visualize that geometry right here. And it's in there, but it is very tiny. So let's grab this one and go to visibility off. And there it is, all tucked in there, all nested. And I think that one's gotten so small, I better give them a little more money. I'm going to step them up too, so I have some higher numbers here, because your division is also having an effect on it. And I'm going to put that, edit the pricing back up to about $6 per step. And you can jitter this. You can do a whole bunch of wonderful stuff with this. It takes a few seconds to run, but visualizing this data, there we go. We're back on a pretty good model with what I had. And our initial model was this one. So this one's behaving a lot smaller for data visualization, but I don't so much mind it. I am going to hide that one, move this one over, bake this one. Just a totally other predicted values coming out to drive this geometry. And you end up with these kind of abstract forms. Let me leave my command. And let's take it to a bake. And we'll do layer 4, yes. There we go. And we could just swap back and forth. It's not good to have things in the technical or the artistic. It does slow down if you have a lot of data and you're driving a lot of forms. So I don't recommend it, and I don't recommend it for the sense of crashing out just to get an image up. But give it a minute, it should be fine. Yeah, just playing around with it, trying to get something to move a little quicker in here. Oh, that's an interesting analysis. Pen is okay. Yeah, not a bad color display. I have the one that I can hide. Now I can swap out the 2 as I go and leave my grasshopper. So you kind of analyze that data. And it really is just data visualization through running machine learning and coming to understand some of the most basic types of machine learning, because I've never been able to wrap my head fully around it, but this is really helping. So we can just swap out of a couple of different models. Actually, I'll put the other one in, and I'll bring this one to, let's just bring it to an EMAP. That should be fine. Just give it a second. You'll have to hide this one away somewhere as well. I think we're good. Just tuck it in there. Shrink it down. It seems to want to jump too big. And I think, there it is, get a nice emap on 1. So that little emap shape, which is a data visualization of this k nearest neighbors, pairs against another iteration of it using the exact same script, but just playing through a little different data to drive my NumPy arrays. So I'm not hard coding things, I'm making these scripts parametric to see what geometries can be driven by them. And I'm not using anything complex at all. My grasshopper skills are not being tested while working with circles and simple pipe tools. Probably a wise thing to do would be to do a mesh pipe. I didn't think of that, but it makes a lot more sense now to grab that and deal with that mesh pipe instead of this one. So instead of untrimmed surfaces, you now have meshes. This one I can take off. That would make a lot more sense to be doing that. 70 milliseconds compared to 368 milliseconds. So that makes sense to speed up the script. So let's, oops, I didn't mean to do that. Grab this one, hide it away, and then swap, this one for that one. We'll have to get rid of those, and then it's not going to look as nice as a mesh, but may as well play around with it. Put that on level 4, group it, and now we should have a nice generated mesh, which is a little easier to look at. I'm not sure if the analysis of that one's going to be worth experimenting and looking at, but it should go fairly quickly. There it is. Yeah, it's not bad. I mean, as a line drawing tool for that one to move quickly, I could swap that out from the other one. So yeah, I'm playing an awful lot with data visualization. One object in front of the others. The other one's a little slower because it's NURBS. And I think I've got it. I didn't read through everything here, but it's the same system. I'll give a sample, then I'll make a Wickerson Studio example of it. I'll take notes on what it means, that algorithm, k nearest neighbors, just so I don't forget. I may nest a little bit of that script within here, exactly the similar script, and I will always try and alter the script in some fashion so as to not, just go from a text version. So that's the one, and the one above was the k-means, the exact same setup, and I think I did one example with that. And then linear logistic regression I thought was interesting, so I did 2 different versions of that as geometries. This one's actually pretty nice. If I take that one preview on, I probably have the script off, so just let me run those, enable, and we'll see what happens. Yeah, there it is. So we'll grab that and we'll hide it away, and we'll grab that one, hide it away, and we'll see what we have here. There it is. Pretty simple script. It's nothing too fancy. That was one of my earlier ones. Not saying I'm loving the geometry. There was the other one, and this one I think I have off as well, enable. And I'm kind of getting off track here. I'm 4 into 10 of these algorithms, and I'm enjoying it. This one actually I like a lot. To bake different forms and really drive the geometry through k-means clustering. I think that's a really fun one, and just changing the price of something will change that geometry so tremendously. So if you're an artist that likes abstract work and you really want to come at conceptually and say you do coding, I actually really like this kind of cushion furniture that's being generated by this. I just love this script. I can't believe I made it, but anyway, I'm getting sidetracked. Then I went back and I did logistic regression, and then I did linear regression. Lots of samples. I keep pushing this down because this script keeps getting more and more. I keep importing more and more and more into my code. So if you're into this and you want to have get involved in what's going on, simple geometries, parametrically playing, then jump on my Patreon. It's a $3 tier level. And you'll be able to get access to all of these ghPython scripts. As I save this one, you can see that these are just a taste of what's on my desktop right now, but there's going to be there'll be tons of them tucked away, and then I'll have the master copies too, the intermediate, advanced, and the advanced master copies that'll have everything in it. So I'm just going to copy that one over and just save it. It already exists, so I don't need to save it. And this will start to make more and more and more sense as we go. I'm just going to select a few things, turn it blue because I like that blue. This file's growing, so just to set you up for where we are next time. I know I'm rambling on. I don't mean to waste your time, but I figure if I'm doing it and you're being experimental with this, and if you want to have a conversation, just reach out to me. This one's going to be 5, and then we're going to grab this one, and we're going to do what everybody's excited about, and this will be definitely neural networks analysis in one line. And that's the real strength of this, is that I'm writing these scripts in very minimal means. So thanks very much for watching, and I'll talk to you soon.